Hello everyone, welcome back to the computer network course. So in our previous video, we have seen the IP. We have started with the IP, Internet Protocol, and version 4 we have been studying, right? So we have seen the datagrams, right? The packets in network layer are called datagrams. Then we have seen the format of datagram. Datagram contain header part and data part. Then we have seen the format of header. Header contains version, then length, then total length, header length, total length, right? And check some options and all. And then there we have left the second row, right? Identification, flags, and fragmentation offset part. I told you we have been studying that in the fragmentation video, right? So here comes the fragmentation video. So in this video, we will study about fragmentation. Okay. So as I say fragmentation, the first thing will come to our mind is the parts, right? The fragments means we have to, fragmentation means to make fragments or to make parts of a big thing, right? That's its fragmentation. Now here big thing is datagram only. We have been discussing about datagram. So here big thing means datagram, right? Datagram is being transferred from source to host to destination. Right, so means we have to make fragments or parts of our datagram. Is that what is mean by fragmentation here? Right, fragmentation means we have to make parts, fragments of our datagram, right? So now why we are making fragments? Why fragmentation is required in this datagram? Let's study this. Okay, it's very interesting. So let me share my screen. Okay, so let's see why we need fragmentation. Okay, so let me take an example. Suppose this is a network. This is host network, and here's the network of destination. This is one network. This is one network, and this is router. Okay, host to destination. Okay. Now here, the MTU of this network is, let's suppose, 520. And MTU of this network, let's suppose, is 200. Okay. Now, what is MTU? Right? MTU is maximum transmission unit. Maximum transmission unit. It means maximum how many size of datagram it can transmit. Its size is 520. Now its size is 200. Now here this host can transfer the datagram size of 20 can be of minimum 20 can be of header size, and 500 is data size. So this size is 520. Now here 180 is data and 20 is header. Okay, so now if it has to transfer 520 byte of datagram from this to destination, then destination MTU is only of 200 byte. So now this 520 size datagram cannot be transferred from the host to destination, right? Destination cannot take this because destination his MTU is 200. Right, so that's why we need to divide our datagram so that destination can receive that datagram. Okay, so every network has its MTU, its maximum transmission unit, which size, how much size of datagram it can receive. Okay, so MTU is maximum transmission unit. So here the destination MTU is just 200 bytes. So that's why we need to divide our datagram into fragments. Now source doesn't divide our datagram. Source has sent the 520 byte of datagram. Who divide the datagram is router. Okay, router divides our datagram. Routers see that, okay, so here the MTU is just 200. So I have to divide my datagram into fragments. Okay, so here 520 and here 200. So it has to be divided between of, let's suppose, first maximum it can be of 180, 20 of this, then 180, then here is left is 360 and minus 500 is 140. Okay, so here I router divided this datagram into 3 fragments, 140 size, 180 and 180 size. Okay, so now, okay, so router divides a datagram into fragments. Why? Because MTU size, the maximum transmission unit of destination, is less than the that of host. Okay. So, okay, we have understood why we need fragmentation. Okay. Now, our network sends one datagram. Our network sends one datagram from host to destination. If it sends one more datagram, then it sends 3, 4 datagram. Then for every datagram, router fragments it, right? So receiver at destination, it receives so many fragments, right? Now, how it identifies which fragment is of which datagram, right? So for that, we need that 3 fields. Okay, I have left that in when I discussed in previous video the header format of datagram. I have left that second row: identification, flag, and fragmentation offset. So whenever a router divides a datagram into fragments, then all the header thing is copied. Just 3 fields are changed. That identification, flag, and fragmentation offset is changed. Okay, and all the datagrams, all the fragments are reassembled at destination only. It is logical, it makes sense, right? So that when all the fragments are received, then only the reassembling of fragments take place. So reassembling of fragments take place at destination end, and router divides a datagram into fragments because of MTU, maximum transmission unit. Okay. So now here, host transfers so many datagrams, and router divides each datagram into fragments. So now destination receive first fragment from this datagram, second fragment from this datagram. So how it identify which fragment is of which datagram, right? So for that, we need first field, that is identification. Means if I send my 500 this datagram, this 3 fragments of this datagram, then I have given the unique ID to this, that is, let's suppose 10, 10, and 10. So if destination receives fragments of unique ID 10, 10, 10, then it will think, okay, so the fragment belongs to this datagram only. Okay, so for another datagram, I suppose I given them 12, 12, 12 fragments, 12, 12, 12 unique ID. Okay, so by this, by identification, destination will able to identify the fragments belong to which datagram. Okay, so second thing is clear. First, identification is clear. Second thing is fragmentation offset. Now, why we need the fragmentation offset? Because here let me just write it quickly. 500, first is of 120, second is of 180, right? Third is of 180. Here is the destination. Maximum is 180, right? So now here fragmentation offset. Why fragmentation offset is needed? We have given unique ID 10, 10, 10. Now destination can receive this fragment first, this fragment first, then this fragment, right? How it identify, how it have to reassemble. It have to be reassembled in order wise, right? So for that, we need fragmentation offset. Okay. Now, let's suppose, okay, our datagram maximum size is 65535, right? I think I forgot to mention in the previous video. So our datagram maximum size is 65535. Okay, in which 20 can be of header size, then left 65515 is of data field. Okay, so this is the maximum size of our datagram. Okay, so now let's suppose in the worst to worst case scenario, I have fragmented my datagram, right? Router fragmented. Then if last fragment is of 1 byte, let's suppose fragmentation is there, and in worst case scenario, last fragment is of 1 byte. So fragmentation offset means how many fragments ahead of me, right? It tells you the relative position and how many fragments ahead of you. Okay, so how many fragments ahead of this fragment? This fragment is 1. So for this, how many fragments ahead is 2. So for this, how many fragments ahead of this is 65515 minus 1, that is 65514. Nearly it is 2 to the power 16. right? And if you remember the fragmentation offset, it fields is of 13 bit. That means 2 to the power 13, right? Now how it can be represented? So for that we need what? I have already discussed. We need what in HLN? What we needed? The scaling factor. So here also we need scaling factor. To divide 2 to the power 16 by 2 power 13, we get 2 power 3. That is 8. So 8 becomes our scaling factor in fragmentation offset. Okay, so understood why we need the scaling factor? Because size is only of 13 bits. Okay, so to represent all the bytes, we need a scaling factor. Okay, it working is same as we have discussed in HLN. Okay, so now I have divided this. So my fragmentation becomes 180. Here, this is my fragmentation. Okay, how my fragmentation will divide now? So I have to divide my this into parts, right? So my scaling factor becomes 8. So here the first fragment. So ahead of this is no other fragment is ahead of this. So 0 by 8 becomes 0. And ahead of this is one fragment that is of size 180. So 180 by 8 becomes 22.5. Okay, problems are not going to end. Now comes 22.5. So how I'm going to divide that 0.5 thing? So, okay, let's solve that problem now. So 22.5 comes, why 22? It comes in point because ahead of this is 180. That is not the multiple of 8. So here we have come to the conclusion that fragmentation, the offset, the fragmentation should belong to the multiple, should be in multiple of 8. Okay, so to make it multiple of 8, we can add the bits or we can remove the bits. Now here maximum size is 180 only. So I can't add the bits. So I can subtract the bits. So let's remove 4 bits. So here it comes 176. Here also 176. Then I have removed 4 bits from second and from first. Then here I have to add that 8 bits. So this comes my new fragmentation. So now let's calculate the fragmentation offset. So here 0 by 8 is 0. And here 176 by 8, it is 22. And here my 352 by 8 is 44. Okay, so this is my fragmentation offset. Okay, now you are wondering if we need to have the last fragment also of multiple of 8. No, it's not necessary to have last fragment of multiple of 8 because we don't have to add this because there is no more fragment. So we don't have to add this, right? So last fragment can be a multiple of 8 and cannot be. It's not a necessary thing. Okay, so yeah, fragmentation offset. So 0 represent means it is first fragment, right? Okay, so we have calculated fragmentation offset, the relative position of fragments. Okay, then the last thing there is flags, right? 3 fields: identification, flag, and fragmentation offset. 2 we have discussed. Now flag field. Flag field is of 3 bits. First is not used. Second is DF. Third is MF. Second is DF means do not fragment. Third is more fragment. So do not more fragment. Let's discuss more fragment first. More fragment means if it can be fragmented or not, right? So if its value is 1, so here it can be its first fragment, right? So it can be further fragmented, right? So its value is 1. Here its value is also 1. It is last fragment, right? So it can't be further fragmented, right? So its value is 0. So if MF value is 1 means it can be further fragmented. It's not the last fragment, right? And if its value is 0 means it's the last fragment, means it can't be further fragmented. Okay, more fragments or not. MF means more fragments, if it contain more fragments or not. So if its value is 1 means it contain more fragments. If its value is 0 means it's its last fragment, it does not contain more fragments. Okay, then second is do not fragment. If a network here sends a datagram to router and here the field becomes 1, it says, okay, I have sent you that's 500 size, and but the condition is don't fragment. Sender sends a datagram, and the df value is 1. So 1 means don't fragment. So router says, okay, you have told me not to fragment, but the MTU size here, destination MTU size is less. I have to fragment. Now what router will do? It discards that fragment. It discards a datagram because it has no other option, right? Sender already given the condition is don't fragment my datagram. So what router will do is router just simply discard that fragment, that datagram. Okay. And if datagram, this don't fragment value 0 means it can be fragmented. Okay. So we have been clear with the fragmentation part, right? Fragmentation means that every network has its own MDU, the maximum transmission unit. Okay, so for that, we need to fragment so that it can be easily transferred. Okay, so for that, we need fragmentation. Now here the MDU is 200, it's less than that is that of 520, so we need to fragment it. Okay, then identification. So network can send many datagrams, right? How the fragments is distinguished. So for that, we have given a unique ID to each fragment. Okay, then fragmentation offset. Fragmentation offset tells you the relative position, how many fragments are ahead of you. Okay, then for that, we need a scaling factor of 8. Okay, then flag tells you if you can fragment it or not, and the more fragmenting, if it is of first fragment or it is last fragment. Okay, so fragmentation is being clear to you. Then in the next video, we will discuss another interesting thing, that is options. In header field, options is there, right? So we will discuss that in our next video. Okay, so thank you.